Assalamualaikum warahmatullahi wabarakatuh and a very good day everyone. So today, my group will be explaining about the ultraviolet visible spectroscopy. I am from group 1. So, my name is Syed Shazwan bin Syed Rosnizam. My metric number is A4684.
So, my name is Muhammad Safi Naufal bin Muhammad Razmi and my metric number is A4423.
So my name is Muhammad Akmal Syed bin Basri. My matrix number is A4971.
Hi, my name is Muhammad Fatih bin Ahmad Nasir and my matric number is A4098. So, let's get into our point.
Hello everyone. Today we are going to explore an essential analytical technique known as ultraviolet visible spectroscopy or UVVs. This method is widely used in chemistry, biology and material science to analyze the absorption of ultraviolet and visible light by a substance. Understanding UVVs can help us identify compounds, determine concentrations and study reaction kinetics. But first of all, what is UVV spectroscopy? Yeah, I know that most of you didn't ever heard of it. So basically, UVV spectroscopy is based on the principle that molecules absorb light at specific wavelengths. When a sample is exposed to ultraviolet or visible vis light, electrons in the molecule get excited and move to higher energy levels. By measuring the intensity of light absorbed at different wavelengths, we can obtain valuable information about the sample. Got it?
Alright, so how UV spectroscopy function? The fundamental principle of UV spectroscopy is based on absorption of light by molecules. When a beam of light passes through a sample, certain wavelengths are absorbed while others are transmitted. The absorbance of light at a specific wavelength is related to the molecular structure and concentration of the substance in the sample. So a UVV spectrophotometer consists of several key components. First is a light source that emits UV and visible light. The second one is a monochromator to select a specific wavelength of light. The third is a sample holder where the solution material is placed. Fourth is a detector that measures the intensity of transmitted light. So the fifth is a data processor that convert the light absorption into an absorption spectrum. The resulting spectrum provide a specific wavelength which correspond to different electronic transition within the molecule. The information help identify and quantify substance present in the sample.
So, how does UV visible spectroscopy work? UV visible spectroscopy works by measuring the absorption of ultraviolet UV and visible vis light by a sample. Here's a breakdown of the process. First, light source. The instrument uses a light source that emits UV and visible light, typically a deuterium lamp for UV and a tungsten halogen lamp for visible light. Second, monochromator. The light passes through a monochromator which select a specific wavelength of light to analyze. Third, sample interaction. The selected wavelength of light is directed through the sample where molecule absorb specific wavelength based on their electronic structure. Some light is absorbed while the rest passes through. Fourth, detector measurement. A detector measures the intensity of transmitted light and compare it to the original light intensity. And lastly, data processing. The instrument generates an absorption spectrum showing how much light we absorb at different wavelengths. This spectrum provides information about the sample's identity and concentration.
So hello guys. So now I will be discussing about the absorbance spectrum of the blue pea flower as represented in this graph. This graph shows the relationship between absorbance and wavelength, helping us understand how the flower interacts with light. So we go one by one. So the first one is the x-axis. The x-axis represents the wavelength of the light in nanometers, nm, which ranging from 400 nanometers to 700 nanometer. This range corresponds to the visible spectrum of light. Now let's go to the y-axis. So the y-axis represents absorbance in arbitrary units, AU, which indicates how much light is absorbed at a particular wavelength. Higher absorbance values mean that the sample absorbs more light at that wavelength. Now let's focus on the key features of this spectrum. We observe two significant absorbance peaks. The first peak occurs at 575 nanometers and the second peak appears at 615 nanometers. These values are marked on the graph as lambda max, which represents the maximum absorbance at those wavelengths. This peak suggests that the blue pea flowers absorbs light more strongly in the yellow-orange and orange-red regions of the spectrum. This absorption pattern explains why the flowers appears blue or purple to our eyes, because it absorbs the complementary colors and reflect the blue-violet light. In summary, the blue pea flower shows strong absorbance at 575 nanometers and 615 nanometers, which is influence its precise color. Understanding the absorbance spectrum of natural pigments can be useful in various fields, including food coloring, fabric dyes, and even medical research. Thank you for watching.
So, to summarize, I believe that UV spectroscopy is a fundamental technique with broad applications in scientific research and industry. By understanding how light interacts with molecules, basically we can gain critical insights into chemical compositions and reactions. Whether in a research lab or industrial settings, UVs remains an indispensable tool for scientists and engineers alike. That's all from us. Thank you for listening. So, to summarize, I believe that UV spectroscopy is a fundamental technique with broad applications in scientific research and industry. By understanding how light interacts with molecules, basically we can gain critical insights into chemical compositions and reactions. Whether in a research lab or industrial settings, UVs remains an indispensable tool for scientists and engineers alike. That's all from us. Thank you for listening.